Okay, today we're going to look at still Chapter 8, Factoring Expressions and Solving by Factoring, but we're going to Section 8.4, Special Products. So we've got a few special products, and if you remember these are going to make your life a lot easier as far as when you're factoring. And the first one we have is called the difference of two squares. So some a squared minus b squared. And all that factors into is a plus b times a minus b. Okay, and if you multiply that back out, that's a squared. That's plus ab minus ab. Those cancel, and then minus b squared. So that's why it's special, because the two middle terms cancel each other. Then we have the difference of two fourth powers. And so basically what we're going to have is we're going to have the similar thing here, except instead of having the a plus b and a minus b, it's going to be a squared plus b squared times a squared minus b squared. Well, a squared minus b squared is a plus b times a minus b. And so that's what we get. Now, when I'm going through examples, what I'll do is I'll split it into the a squared plus b squared times a squared minus b squared, and then split the a squared minus b squared into a plus b times a minus b. But if you know directly, you can go from here straight to that if you need to. And we also have things called perfect square trinomials. And those are the form a squared minus 2ab plus b squared. And they factor into a minus b squared, or if we have a positive in the middle, then it's a plus b, the quantity squared. So depending on if you have a plus or a minus, depends on if you have a minus or plus here as well. Now note, a squared plus b squared is not factorable. So if you come to a point where you have some sum of two squares, you can't factor that. Now we do have something called the sum or difference of two cubes, and so we can take the difference of two cubes, so some a cubed minus b cubed, and basically we take just the a piece minus the b piece. Now this is a key here. This term, our sign, matches the sign of this one, and then we take a squared, so we just take that a and square it, plus, now we switch signs here, and then it's a times b, whatever that is, and then plus b squared. And it's always going to be a plus here on the end, and we just square the b. Now, if we have the sum of cubes, the only thing that changes is we have a plus here and we have a minus here. So this plus corresponds to this, and then the next one is the opposite, and we still always have the positive b squared. Now, some people like to remember an acronym or something like that, and so SOAP is one, where S, that's the binomial, has the same sign as the original expression. O, that's going to be the middle term, has the opposite sign as the expression. So this is going to be the middle term of the trinomial. It has the opposite sign, and you can see this one was plus, that one's minus, they're opposite. And then AP is, the last term is always positive, AP. And so then it's always going to be a positive, and so that's kind of how to look at this. Again, if you just remember the sign of this and the sign of the terms with just the binomial are the same, and then it has the opposite middle term, we're good to go because we always know the last term is positive. But again, SOAP helps some people. All right, so I'm just going to go through here and kind of explain what they are and then just factor them. So first one we have is v squared minus 25. Well, 25, what is that? Well, that's just 5 times 5. So this is a difference of squares. And so that just goes v plus 5 times v minus 5, because we know 25 is equal to 5 squared. And so when you have that, that's v squared minus 5 squared. That's a difference of squares if you look at it that way. And we can just factor into this. Now, what about the next one? Well, the next one, I see we have a common term in both of these. I can put and take out a 4. A GCF of 4 taken out is going to now make this 4x squared minus 9. Now, what does that look like? Well, it kind of looks like a difference of squares again, because 4 is 2 squared, 9 is 3 squared. So what we have is 4 times 2 squared x squared minus 3 squared. And so now if we take the difference of squares, that's going to be 2x plus 3 and 2x minus 3. Okay. And so that's going to be our factored form of this. And remember, to keep that 4 out in front, we factored it out. It's still part of the thing. And so that whole piece here, the 3 different terms, are going to be our factorization of this difference of squares. Now this one looks like a perfect square trinomial with the middle term being negative. Now if you can't remember what that looks like, that goes, and the middle term being negative, we just get a minus b, the quantity squared. Well, what I'm going to do is I'm going to also look at it as, well, I know it's going to be a and a. The factors of 1 are 1 and 1. And this to be positive here but negative here means they both have to be negative. And since that's the factored form, or we can go straight to a minus 1, the quantity squared, using our formula. So we can go straight to here, or we can do the trial and error and factor this. Well, a squared can be only a and a. 1 is only 1 and 1. This to be positive has to be negative and negative to get that negative in the middle. Okay. All right, what about the next one? Well, thinking about this again, this could be a perfect square trinomial, except this time we have a positive in the middle. And so what is this? This is really 5 squared a squared plus 30ab plus 3 squared b squared. And so if we know it's going to form this except with a plus in the middle, well, what's the first term? It's 5a. And then it's going to have to be plus. And then the last term is 3b. And that's the quantity squared. And so that would be our factor form using our formula, or we could look at it as, okay, well, what do I need to break this apart as? Well, 25 is 5a and 5a, going back to how I always use the middle kind of terms to look at it. And 9 is going to be, and it's plus and plus, so it's going to be plus 3b plus 3b. And again, I can always check. Multiply that out, that's 25a squared, check. Then I have 5a times 3b, that's 15ab. And here's another 15ab, so that's 30ab. And then 3b times 3b is 9b squared, okay? So always check your and multiply it back out and FOIL it or whatever it is, and make sure you have the correct answer. All right, here, what do we have? We have x cubed minus 64. Now, when we see that cubed, that makes us think, this could be a sum or difference of cubes. And because we have a negative here, I'm going to say it's a difference of cubes. So now I have to think about what is 64? Well, 64 is just 4 cubed. So I really have x cubed minus 4 cubed, which is the difference of cubes. And so I remember that that's going to be x minus 4 times, now we square the first term, then we change it to plus because it's opposite of this one. Then I take 4 times x, so that's 4x. Then plus, I square the last term, 16. Okay, and so then that would be my factored form using the formula at the beginning. So again, if we go back to the beginning, our difference of cubes is going to be the a minus b times a squared plus ab plus b squared, which is what we've done here. The a plus b, so a minus b times a squared, and then plus a times b plus b squared. Okay. All right, so this one, well, I noticed they're both even, and 54 isn't a perfect cube. 250 is not a perfect cube. So let's take out a 2 first and see what that gives us. Well, that gives me 27x cubed plus 125y cubed. Now I can't factor anything else out here, but I recognize 27 and 25. 27 is 3 cubed, and 125 is 5 cubed. Okay, so now I've got 2 times. Now I'm going to do the same thing here, except instead of a minus at the beginning, I'm going to have a plus here. And so that's going to be a 3x plus a 5y, then times. Now I'm going to take 3x and square it, so it's going to be 9x squared. Now I have to have the opposite sign. Now I take 5 times 3 is 15, x times y is xy, so I'm minus 15xy, and then plus, and then I square the last term, that's going to be 25 y squared, okay? And so then this whole thing is going to be the factorization of those initial terms, which then I factored out of 2, so then I got the sum of cubes. And so that's the sum of cubes part here, and then I had the factor of 2 out in front there. All right, let's go to the next one. So the next one is interesting because we have 16 and a z to the fourth. Well, that z to the fourth, that cues me in that we're probably dealing with the difference of force power. And if we remember here, the difference of two force power, what we have is the a squared plus b squared, and then this is just a squared minus b squared. And so let's do it that way and then work our way down. Well, what is 16? Well, 16, if we write that out, is 2 to the fourth. So I've got 2 to the fourth minus z to the fourth. Well, that's going to be 2 squared plus z squared times 2 squared minus z squared. Well, this is just 4 plus z squared times 4 minus z squared. But in this form, I recognize that's a difference of squares. And so I have 4 plus z squared. And then I have 2 plus z, 2 minus z. And then that would be my factored form. And again, I can go directly from here to here based on the formula because it's going to give us the first term a to the fourth minus b to the fourth is going to give us a squared plus b squared. And then it says it's going to be a plus b times a minus b. And so that would be something we get to directly. Or if we need to go down in pieces, we can do it that way as well. All right, well, we see another fourth. We see it's a difference. So that really is m to the fourth minus, well, what is 81? Well, 81 is 3 to the fourth. Then we have b to the fourth. So now if we go straight to this, what we can do is we can say, okay, well, we've got m squared, and then we have plus, because we're going to have the adding of them first, and we square this. 3 squared is 9b squared, so it's going to be 9b squared. And then what we have is this. We have m plus 3b and m minus 3b. Okay, and so that would be then our final format. And again, that's using the formula directly from the very get-go. All we had to do was plug in our values for a and b, and we got our answer. Now we could have gone down like we did here before and had m squared and then minus 9b squared, and we could have had then times m squared plus 9b squared. Well, we can't factor the sum of squares, but we can factor that into m plus 3b, m minus 3b, and then we still have our m squared plus 9b squared. And so those two are what matches. And again, this was just directly from knowing the formula, and we could get it directly. All right, 9a squared minus 1. What does that look like? Well, the 9 is really just 3 squared, and then we have a squared minus 1. Well, guess what? 1 is 1 squared too. And so we have a difference of squares. And so that's going to be 3a plus 1 and 3a minus 1. Now, if we want to check, 3a times 3a is 9a squared. Then we have 3a times a minus 1 is a minus 3a. And a 1 times 3a is plus 3a. So those cancel. And then 1 times a minus 1 is minus 1. And so that is going directly as a difference of squares. All right, so what about this one here? Well, we see that there is a factor of 5 here, so we can pull out a 5. So what does that give us? 5 times, well, 25x squared plus 9y squared. Now, does that give us anything? Well, not really, because what we have is the sum of two squares. And that's 5 squared, and that's 9 squared, but we can't do anything with the sum of squares. And so all we have is we could factor out a 5, and that's as far as we could go on that one. Okay. Now, if that had been a negative in the between, we could have done the difference of squares, but because it's a sum, we can't factor it any further. All right, what about the next one? Well, this looks like one of those special products again. And you can do it two ways. You can do it as, trial and error. So what are the factors of 4? Well, again, I'm going to try 2 and 2 because of the innermost. It's going to be plus and plus because they're both plus. So that's k squared. We have 2k plus 2k is 4k. 2 times 2 is 4. And we have that. Or we could have recognized that's a perfect square trinomial, and that's going to be k plus 2, the quantity squared, which is what this is, but this is written out in short form. Okay. Now the next one kind of looks similar to that. It looks like a perfect square trinomial too, because this is half of this, and multiplying it all out. And so I think what I'm going to say is, let's do it by trial and error and then see if it matches. And if it matches, it's going to be x minus 4y, the quantity squared. So let's see if that works. Well, here we have x. Both of these being plus and negative, we're going to have both of these be negative. And now the factors of 16 that add to 8, well, that's going to be 4y and 4y. So let's check it. X squared. We have minus 4y, or 4xy, minus 4xy more, so it's going to be minus 8xy. And then 4 times 4 is 16. Y times y is y squared, and it's a positive. And so, again, we could have this one with the trial and error, or we could have got this one directly using the perfect square trinomial with the negative in the middle. All right, the next one. Well, it looks like we have factors of 5 here. So I'm going to say that's 5, and that's going to be 4x squared plus 4xy plus y squared. Now, what do we have here? Well, let's see if we can factor anything. Well, 4x squared, I'm going to try 2x and 2x, just because, those are the middle terms. And then it has to be plus and plus. Well, then the only thing of factors of y squared are y and y. So now let's check and see if we FOIL this out, we get back to here. So that's going to give us 4x squared. And we'll have 2xy plus 2xy, that's 4xy. And then y times y is y squared. So that gives us that. If we multiply here, that's 20x squared plus 20xy plus 5x plus 5y squared rather. And so that does give us what we need for our answer. Now again, this is one of those perfect square trinomials, so we could have wrote that as 2x plus y, the quantity squared, and that would have been our solution as well. So either way, gives you the same answer. This one's just written out both terms. This one has both terms in the squared here. All right, so what do we have next? We have 375m to the third. So what are we going to do with that one? And it's plus 648n cubed. Let's see here. 7 and 5 is 12, 13, 14, 15. 5 and 1 is 6. So that's divisible by 3. And this is 8, 12, 18, 8 and 1 is 9, so that's divisible by 3. So let's factor out a 3 first. And the only reason I'm doing that is because I don't recognize those numbers as perfect cubes or anything like that. So let's try factoring those out and see what we get. Well, if we take out a 3 here, that's going to give us 125m cubed. And then plus, and if we factor out a 3 here, that's going to give us a 2, a 1, and a 6 n cubed. Okay. Well, 125, that's easy. We know that one. That's 3 times 5 to the third, m to the third. And the next bigger one after that, that's going to be 6 cubed, n cubed. So now I've got the sum of 2 cubes. Okay, so we can use our formula. And so we're going to have a plus here, and then we're going to have a negative in the next one. So we have 5m, then plus 6n. Then we have the 5m squared, so that's going to be 25m squared. Now minus, because we have to have the opposite sign. And now we multiply the two together. So 5 times 6 is 30m n. Then plus again, our last one's always plus. And then 6 times 6 is 36. And then n squared in parentheses. And so that whole thing is what we're going to get. So we had to factor out that 3 first so we could get perfect cubes, and we could take the cube root of that and get 5, and cube root of that is 6, and then we could factor in the sum of 2 cubes. Okay. All right, so here we got both of these have that fourth power again, and so we know we're going to have the difference of the fourth powers, and so we know that means this one and this one. Well, what is 1? Well, that's 1 to the fourth. That's into the fourth. So we're going to have n squared plus 1 times n plus 1 times n minus 1 if we just follow directly our formula. Now, if we don't follow the formula, what we're going to have is n to the fourth minus 1, and that's going to give us an n squared and an n squared. And then 1s are going to be 1 and 1. And it's going to have to be a plus and minus because it's going to be like the difference. So you're going to cancel if you have a plus and a minus. Now we notice that that's again a difference of squares. So that's going to give us n squared plus 1 times n plus 1 times n minus 1. And lo and behold, we have our same thing on both of them. And again, we can't take the sum of uh, squares and factor that. And so that is not factorable, but our difference of squares we could factor. All right. How about this one? Well, what is 81? Well, that's going to be 3 to the fourth c to the fourth minus, well, 16 is going to be 2 to the fourth d to the fourth. And so we're going to have something similar to this one. We're going to have a 3c minus 2d. And that's going to be, well, actually, let's do the plus first. We'll do our plus one first. We should do that always, if possible. And so it's going to be our 3 squared c squared, so it's going to be 9c squared plus 2 squared is 4, d squared is d squared. And now we have our a's and b's only, and so that's going to be a 3c plus 2d and a 3c minus 2d. And so then that would be our factored form. Now, if we did like we did over here, what we would have is going to be 9c squared and then plus 4d squared times 9c squared minus 4d squared. And again, checking that out, that's 81c to the fourth, and then plus 36 minus 36, so those cancel, and then plus 6 or minus 16d to the fourth. And so that's that. Now this can be factored. So 9c squared plus 4d squared. That's going to be 3c plus 2d and 3c minus 2d. And again, lo and behold, our formula matches what we do if we do it longhand and go all the way down. Okay. And that's all I have for you today for this section.